Good morning and good afternoon, everyone. Again, I am Ray Huff. I run our greenhouse gas verification and reporting practice for the Western United States, and depending on the situation, even further east than that. I am going to be basically the intro for Monte's presentation, and what we wanted to do was make sure everybody had a good baseline understanding of greenhouse gases, the carbon cycle, how all this works. So what I'm going to do is breeze through a lot of these slides, but I know that there's some people that are unfamiliar with things like carbon markets, verified emission reductions, and how the cap and trade system works. So with your permission, we'll cover things as quickly as we can in that regard. So first of all, hopefully everybody understands what the greenhouse gas effect is. It is thermal radiation that comes in from the sun as solar radiation gets reflected off of the surface of the planet, and it gets entrained or captured in the atmosphere based on gases, carbon dioxide, methane, sulfur hexafluoride, a whole bunch of other ones, and it ends up warming the planet. Again, there are very simple illustrations out there, but I just wanted to make sure we all understand the basics to it, because GHGs and greenhouse gas and carbon neutrality, they become the coin of the realm or terminology that everyone uses. But you know, every once in a while, I think it's good to go back to the beginning and understand what all these terms mean. So what are these greenhouse gases? Well, there's a group of gases that were specified in the Kyoto Protocol, and primary among them are carbon dioxide, methane, and nitrous oxide. There are also hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride. There's a lot of other compounds that are there, but again, the three majors are going to be carbon dioxide, methane, and nitrous oxide. But the question may come up, why these GHGs? What's so special about them? Well, all greenhouse gases have what's called a global warming potential. And that global warming potential is compared to the base level situation of carbon dioxide in the atmosphere. So if the global warming potential for having carbon dioxide in the atmosphere is 1, well, methane is 21 to 25 to 28 or more times as much of a global warming chemical. It will last that much longer in the atmosphere. The same thing with nitrous oxide, the fluorocarbons, and sulfur hexafluoride. You can see that sulfur hexafluoride has a significantly high global warming potential, but there's not as much of it in the environment. So again, it's important to know. And these global warming potentials are based on, again, their infrared absorption of gas and the lifetime they live in the atmosphere. You can see the numbers I'm using are from a 1996 assessment report done by the IPCC. There are more recent ones, and I have heard everything from 21 for methane to 100 for methane, but there are agreements on which is going to get used for things like regulatory reporting. And right now, I believe we're in the 25 range for methane. So how do greenhouse gases work in the carbon cycle? Well, there's biogenic sources and there's anthropogenic sources. So really the carbon cycle, you have to imagine biogenic. If a tree grows, it will eventually die and it will rot, returning that carbon into the soil from which other trees grow. Then there's photosynthesis and there's absorption of CO2. That's kind of the cycle. But anthropogenic sources are things such as factories and or landfills, because landfills store carbon, and we'll get into that in a little bit, but they are a man-made activity that changes from the typical biogenic degradation of this material. With that, I'm happy to answer any questions, but again, that was kind of just a primer to make sure we're all on the same page. So with that, I'd like to talk a little bit about carbon neutrality and what is the carbon market. And so we need to start off with, how do you actually get a neutral carbon footprint? What is neutral? And the way you get a neutral carbon footprint is you take a look at what your carbon dioxide equivalent emissions are, and that is methane, N2O, carbon dioxide. It's all the greenhouse gases that you would have, and you look at what your emissions are. Then you would need to offset what those emissions are in order to come up with a zero footprint. So understanding what your emissions are to begin with is the first step in becoming carbon neutral. Then, how do you reduce these emissions? Well, you can actually purchase emissions offsets from the carbon market, and you can also go get alternative power. And you may have heard people saying, oh, I'm going to switch to LED lights from fluorescent or from incandescence. That is a reduction in your greenhouse gas footprint. But there's only so low that you can get when you're reducing your greenhouse gas footprint. Eventually, you will probably need to purchase emissions offsets from the carbon market. And the carbon market, it works both voluntarily and from a mandatory perspective, and it depends on the state that you're in. California certainly has our cap and trade program, and I know there's several other states that have that and or are developing it. So what I'd like to do is talk a little bit about how the carbon market actually works. So here's an illustration from my friends at EcoSecurities. For me, it just makes the most sense of how the voluntary market works, and that is, if you look at the emissions for the company with a pollution target, the one on the left, you can see that they have a target level that is below their emission level. And what they need to do is purchase or offset their emissions in order to reach their target level by acquiring emission reductions from a company that's been able to reduce their emissions and or have a carbon project, such as sequestration, which we're going to discuss today. So it's that reduction or removal of carbon dioxide from the atmosphere that will allow someone to sell these reductions on the market. A company will purchase them. Again, they will offset their emissions and they can meet voluntary and or regulatory targets. So who does this? Corporations, businesses, institutions. This is all on the voluntary side. They may want to have a zero carbon footprint. We've all probably seen when you rent a car, you can offset your carbon emissions, or when you purchase a plane flight, you can offset your emissions. And these companies will purchase emission reductions in order to allow those reductions to offset your trip or the amount of energy or carbon dioxide that would have been created from your trip. There's also speculators that are looking at the regulatory market, such as the California cap and trade market, and seeing that as demand increases for these offsets, the price goes up. Again, these are markets, just very much like the stock market. There are prices and there are daily alerts on what low carbon fuel standard credits go for, what cap and trade credits go for here in California. And I'm more than happy to explain all that in detail, but frankly, that's not the point of today's presentation. So let's see about who's selling. There's carbon asset developers, and we're going to talk a little bit about that today. Monty's going to get more into that, and that is project developers. People that develop projects specifically to obtain verified emission reductions, or VERs, or carbon credits, and then they'll sell them. There's also aggregators, wholesalers, again, very much like the market that you would know of. There's originators, and these are people that buy credits from established projects and they sell to other players. So it's not necessarily a developer, but they could be just a project themselves. There are also retailers that create portfolios of carbon credits in order to sell those. And then there's brokers. There's also carbon funds. And we've all probably heard of those different entities by now. So again, we talked a little bit about the markets. And again, there's voluntary markets, such as the Chicago Climate Exchange, still there a little bit, Climate Action Reserve, the American Carbon Registry, and renewable energy is currently where most of the activity occurs. You can see there were 42.4 million metric tons in 2019, and it almost doubled in 2020. So the voluntary markets create a lot of the credits that are exchanging hands and used in the compliance markets. So there's federal cap and trade legislation that has never gone through. This is not any sort of announcement, but I know it's constantly thought of. Many of the states do have cap and trade legislation, including California, and there's a few other states that are looking at cap and trade legislation. And the way California works is that there are certain amounts of credits that exist, but in order to meet the full requirement of your emission cap, you need to purchase additional compliance offsets. And that's where these markets come into play. So what is it that people are looking for in carbon credits? I mean, why can't I just go out and purchase one from anybody on the street? Well, there's a few tenets to this. And again, the different carbon registries have their own rules, but they're all pretty much the same. And that is, projects need to be voluntary. They need to be something that is not regulatorily required. So landfills, there was a big problem with that when landfills first started looking at carbon credits, because they changed the new source performance standard regulations and brought them in. And so a lot of landfills are regulatorily required to capture gas. And that is why there's not a lot that can be done with landfill gas capture unless it is voluntary, above and beyond what's required from a regulatory perspective. Projects also need to be additional, and that is, again, above and beyond, not just voluntary, but something that you haven't done before. And they must be beyond business as usual. And that's kind of the recurring theme, as you can all see. Also, projects need to be verifiable. That is, you can't say, well, I think this project reduced some emissions. No, you need to measure flow. You need to understand this amount of gas went from a coal mine into a thermal destruction unit. And we removed X amount of methane that would have otherwise went to the atmosphere. So speaking of that, let's get a little bit into some carbon project examples. And again, we're getting to the sequestration. So let's start with methane capture and use. Why methane? Because it's very widespread. There's a lot of different industries that have it, and it has a shorter atmospheric lifetime, but it has that 21 to 25 times global warming potential. So you honestly get a lot of bang for your buck when you reduce methane emissions. And let's look at methane use options. You can take, this is landfill specific now, you can take landfill gas and turn it into electricity. You can use a combined heat and power plant and get electricity and thermal energy. You can also make medium or high BTU fuels and go from a landfill, compress that gas. And remember, landfills generally have 50% methane, 50% carbon dioxide. And so you're going to get a significant amount of methane, especially if you go to a high BTU gas where you essentially remove the carbon dioxide from the gas, and it ends up being almost 100% methane. Other methane sources can be coal mines, and I referenced that a little bit earlier, but let's discuss it a little bit. And that is, there are mines where they basically have to keep the miners safe, and they ventilate the mines, and historically that just goes to the atmosphere. That is business as usual. What would be beyond or additional is capturing that methane. And there are different ways to do it. You can put gob wells, which pull the gas from the coal seam, and those wells are attached to a flare or a thermal destruction unit. There's also ventilated air that they use to make the mines clean, and that air can go to a thermal destruction unit. And all of this is, again, above and beyond what the normal standard is. There's also manure digesters, and this gets into dairies, and that is the business as usual is to have ponds and manure piles. And what if you took that material and put it into a digester and extracted the methane from it and used that to generate power? Again, business above usual. And landfills, we talked about a little bit. You pull the gas off of a landfill and use it for beneficial purposes. So those are the different types of projects. But there's also a whole nother category, and that is sequestration. And this is where not where you destroy the methane, such as the projects I talked about before, but this is where you store it on a permanent basis. And that's really what Monty's going to get into, is the difficulty and the challenge in finding permanence. So there's three general types: terrestrial, ocean, and geologic. Now, terrestrial and geologic, very much related, but terrestrial, you need to think about forests and crops. And looking at it, this is above geologic bedrock. It is securing that carbon into the soil, microbes, and plant roots, and really the organic content in soil. Ocean sequestration, very similar. But today, we're here to talk about geologic sequestration, and that is where you capture carbon dioxide and you inject it deep into permanent carbon storage locations. And with that, the intro is done. Monty, are you ready to take over?
I appreciate that. I appreciate you taking the time to kind of set the stage for where all of this goes. And without all that front end, the carbon sequestration side of it really wouldn't be there at all. So what I want to do is just take a couple of minutes and talk about what it is and why we do that versus other methodologies. So some of the main benefits of geologic sequestration is, it's one of the more responsible ways to handle, carbon and get it out of the biogenic cycle. You can get credits for it. It is permanent. And that's one of the things we'll talk about, because when you look at certain things such as forest initiatives or cropping or things like that, you can have a forest fire, ag practices can change, and things of that can happen in a relatively short time frame. So the durability or permanence of your project can be affected. And that really affects the overall price point and the value of what your project brings to the market. These are also very long-term assets. They're typically more costly to build from a CapEx standpoint, but we'll talk about what some of those things are and the benefits here in the next few slides. So really, when you think about what is carbon sequestration, we'll talk about that in a minute, but the other thing is why. And these balloons kind of give you a decent graphic or a representative graphic of what goes on. But when you inject carbon dioxide into the subsurface, you reduce its volume by over 97%. See, when you think about the huge volumes of carbon that we need to inject to modify, some of the effects of global warming that we see, you got to have some place to put it. So when you can reduce the volume of it 97% by injecting it underground, that's the main benefit. But there's a lot that goes into the development of subsurface assets for sequestration of carbon. And like Ray said, there are a lot of drivers to do this: sustainability goals, market access. We're seeing some of our midstream clients in the midstream energy market who want to do this so they can access European markets. There's the low carbon fuel standard incentives. And Ray really went over who's doing it, but there's a wide range of folks that are getting into the carbon market at this point in time and developing these CO2 projects. There's a lot of graphics out there that you can find to talk about the various sources and CO2 in the environment and in the various sinks. The things we look for are deep reservoirs that are either depleted oil and gas reservoirs or saline aquifers that really have no use. And these are typically between 3,500 and sometimes up to 10,000 feet deep. So they're very deep. They're very isolated from the biosphere and the atmospheric cycle, which is why they're so well suited for long-term carbon storage. When you think about what the market space looks like, this is a rapidly developing market. You hear a lot of people talk about what's going on in the sequestration space, and we're doing several of these projects in things seem to be pivoting and moving very rapidly in response to market demands. When you think about the impact of this relative to the existing fossil fuels industry, a lot of people like to think of this as a binary choice, but it's really not. In fact, one of the main proponents talking about how we implement carbon sequestration is the National Petroleum Council. They, in 2019, put together some excellent guidance documents that are really in lockstep with the IPCC recommendations from the United Nations. And what it does is it talks about how do we modify or adapt to pending regulations such as the low carbon fuel standard. How do you connect sources of CO2 to the sinks or the places you put it? And then what are options out there for smaller scale needs that you put together? And one of the things that the National Petroleum Council put together was, what does that roadmap look like for at-scale deployment for carbon capture and sequestration in the United States? And in the upper, we won't go through the specifics of this, but we'll share the slides so you can dig into it. But in the upper left-hand corner, you can look at where some of the initial projects are currently in the United States. They're in the Midwest, they're in Texas, some of the Intermountain states. But in the next 5 to 7 years, and we're already seeing some of this, you're seeing a lot of rapid development on the Gulf Coast, the Illinois Basin, and other places. But if you move that on down to the next 25 years and look at the amount of subsurface pore space and the amount of subsurface assets that are going to be developed, what that does is it really occupies a lot of that old pore space that we used historically to extract fossil fuels from. So, we took this energy source out of the ground, and now we're going to take one of the byproducts and put it back where it came from in a completely different form. And if any of you are interested, we can give you links to more of this information so you can drill into it. There are projects that have a wide range of applications, like Ray discussed. One of the things that we see is, a lot of activity in the voluntary markets. And so when you look at how things are priced on the voluntary market, it all relates to permanence and durability in the marketplace. And you think about some of these things, and this is publicly available information from Microsoft's website on their carbon removal portfolio. And the reason I pulled this is one of our clients is here that we've helped develop some of these technologies, which is Charm Industrial, through a bioenergy and injection of a carbon-rich oil back into the ground. But the durability of certain projects from a geologic standpoint, like Charm Industrial and Climeworks, are in excess of 10,000 years. Because once you put it in, it gets locked up in the rock and you physically can't get it back out. So that really drives price points on these voluntary markets, and people are willing to pay, orders of magnitude more for these projects because they're very permanent, they're easy to verify, and they're not subject to things that could, such as natural resource disasters or policy changes by governments. So that's kind of the summary of what I had on carbon sequestration projects. And with that, we'd be glad to answer any questions.
Do some states have a more preferable geology and I guess their water tables for this kind of for this kind of geologic solution?
Yes, in fact, they do. If you look at all the guidance documents prepared by the Environmental Protection Agency and the California Air Resources Board that verifies some of these projects, the main criteria is protection of existing natural resources and water supplies, because you want to make sure that any CO2 you inject doesn't get back into a drinking water source. So some areas of the United States are much more preferable. And if you go back and look at areas that historically have produced large amounts of oil and gas, generally correlate well with suitability for underground storage. And the United States Geological Survey has also put together some cool graphics, which are carbon atlases of the United States. And they closely mirror the graphic that we put together that was from the National Petroleum Council as well. So
Okay.
There are correlations, yes.
All right, thank you. Also, for our audience, I just posted a link to a blog that Stephanie Hill just wrote recently, and it does have a chart of the states and where they are as far as regulatory controls, and so you can actually look up your state and see, is this a state that's more accepting of this kind of technology or not? Now, we do have some questions coming in through the chat, so let me ask you those. Aaron asks, do we know if there are any long-term effects of geologic sequestration?
Yes, we do know if there are long-term effects, and they're positive effects because you're removing the carbon from the biosphere. There's a lot of information out there in the industry that we use as analogs. So we've got real data to draw this from. One of them is the gas storage industry, where, and that's a very flammable compound. And, there are decades of experience and lessons learned, quite frankly, on how to put compressed gases in the subsurface and make sure that they stay there. And reflected in a very robust regulatory program for carbon sequestration. It is it has a very high threshold.
How is the evolution at this time about the legislation in this issue?
I can take a whack at cap and trade, and then Monty, maybe you can chime in on the specifics of sequestration, geologic sequestration. As I had said before, I think there are several states that are developing cap and trade, which will be mandatory, and sequestration is recognized as a possible avenue for getting low carbon fuel standard credits here in California. So it is moving into legislation and becoming accepted.
Yeah, I think I would mirror that, Ray. In the geologic side of it, there are a lot of people out there in the voluntary market that are developing innovative ways to put carbon back underground, and they're not always CO2. That's a gas that you then compress and pump in. And so we want to make sure that there's policy initiatives that are being addressed that consider these new deployment methodologies for carbon sequestration. And then there's certain things where you want to make sure, are there old oil and gas wells that have been depleted? Can you successfully convert those? And is it safe? And I saw a question pop up in the chat there. And the answer to that is yes, but those wells have to make sure you're not going to frack, the rocks and create issues with seismicity, water contamination, things of that nature, and then to be able to test those. So when you put something underground, that it stays there.
Thank you for answering that. Can you give a ballpark unit cost to developing this kind of system? Say so much per ton of CO2? Is there how do you go about estimating the cost of these?
Yeah, there are some cost estimating tools that NTEL has put out through the Department of Energy to help with that. They paint with a very broad brush. And we have some idea of that, but at this point we can discuss that as a side conversation, but there's a lot that goes into it relative to your project size, whether you have to have pipelines that go into it, how deep is it? Do you have to compress CO2? You have another alternate carbon source you can inject. So it's not easy to give an answer to that. And that's part of the process, is making sure the economics close.
That's a whole nother session. And that's, I would imagine, very dependent on location and a lot of other factors.
Yeah, there's a lot of variables related to that.
Okay. And a follow on to the idea of converting a petroleum extraction well for carbon injection. Candy is asking if it's technically feasible once the reservoir is depleted.
Yes, it is. In fact, those are some of the sequestration targets we look at when we do screening to help site these, is look for depleted reservoirs. And the reason we know they work is they've held oil and gas for millions and millions of years and kept it from coming to the surface. You just make sure that the wells that were installed to extract it are done properly and will not allow anything to leak.
But that's part of what you do when you're going out and looking at the feasibility, isn't it?
Correct.
A lot of it is due diligence.
That is correct.
Yeah. One other thing, can you discuss biochar and amounts of greenhouse gases produced? Is that a little off topic for us, or?
Well, for me personally, it is. I can certainly talk about landfill sequestration, but the amounts that go into biochar and what it results in, I will honestly say there are probably people that know that are more knowledgeable than I am.
Okay. Are there more states transitioning to renewables from, say, landfill gas, or maybe to landfill gas to RNG or digester to RNG? Are there some states that are doing this faster? For example, California, Michigan, Louisiana.
Those would be them. You're right.
Oh, did I nail them? I know more than I thought. And here's a question. I think this is an interesting one to me. There are a lot of smaller landfills, and they may not be able to have the resources to find partners or to put something together where they could convert their gases into energy or transportation fuel. Do they ever group together? Do you ever see landfills, like smaller landfills, group together to try to take advantage of some of the carbon markets if the infrastructure is in place?
I've seen a little bit of that, but generally the issue is geographic separation, because landfills are fairly far apart from each other because they actually exist based on the needs of taking materials to the landfill. So it's a little bit harder to have them band together, but feeding into the same regional pipeline, yeah, that's possible. And another thing is specific to these smaller landfills, those are exactly the sites where they may not be regulatorily required. And if they put a system in, it is additional and it is voluntary and it is more than business as usual. And with devices such as the microflares that exist and the enhanced approaches that they have to the amount of gas that you can get out of landfills now, they're actually worth taking a look at.
Okay, thank you.
I think one thing to add to that too, if I may, Diane, is there's some folks that are looking at potential revisions to the low carbon fuel standard, where even if you don't produce a fuel, if you produce significant quantities of negative offsets, how can those be monetized under that program? One of the things we're looking at is small scale sources. And is there a pathway to do small scale geologic sequestration and have the economics close? And that we don't have the answer to that yet.
Mm-hmm.
We're looking at it to make sure that there's no missed opportunity out there in the future.
Okay. Now, one of the other things I've been kind of self-involving myself in is taking a look at the federal funding packages that are rolling out. I mean, they're at the federal level now, and you see some grant programs beginning to come out. But I'm keeping an eye on the Energy Department and some other places, but it will begin to trickle down to localities and states, I imagine, this spring and summer. And so we'll want to keep an eye out on any kind of funding that, you know, might be helpful, that people could take advantage of. So we'll post that information as we get it. Here's another question. How many markets currently issue some type of credit for geologic sequestration? I am only aware of LCFS and the $50 per ton federal income tax reduction. Ray, do you know of more?
I know of those two. I would agree with Paul. Monty, you might have more insight, but I know that it's currently used a lot as a voluntary component, as Monty showed, to offset larger corporations' overall greenhouse gas footprints. And so they're used in that non-monetized sense.
Okay. Would like to thank everyone for joining us. And we will be sponsoring more in-depth and targeted information We'll get more technical or more financial as those are developed throughout the year. So we will be sure to invite you to those. And I would just want to wish everyone a happy day and thank you, gentlemen, for joining us today.
Thank you. Happy to do it.
Thank you.
Okay, bye-bye.